Hey, welcome to the podcast.
Thanks for having me.
So, dude, I was reading this physics thing, and man, it just starts with like, hi, you're on a rock, floating in space. I mean, what a way to open, right?
No, that's perfect. The whole vibe is just, it doesn't take itself too seriously, but it's actually explaining real stuff. Energy, motion, all that.
Okay, so like energy and work, right? The text says energy is measured in joules, and it doesn't have a direction. It's just a number. But work, I always get confused about that.
Yeah, okay, so here's the simple version. Energy is like a thing you have. It's a capacity to do stuff. Work is what actually happens when you use that energy to move something.
Wait, so like if I lift an apple up a meter, that's work?
Exactly, and you're using your body's chemical energy to give that apple gravitational potential energy. The text literally says that.
I love how they describe it. Energy is like your bank account. Work is like a transaction. That actually makes sense.
Right? And here's the wild part. If you try to lift something and it doesn't move, you did zero work. Your muscles are burning, you're sweating, but physics says, sorry, doesn't count.
That's brutal. But okay, so energy can't just disappear, right?
No, it converts. Like you drop your phone. It had gravitational potential energy. That becomes motion. Then when it hits the ground, boom, that energy becomes heat and sound and damage.
Oh, and temperature is just like the average motion of atoms? That's kind of beautiful, actually.
Yeah, and this is where entropy comes in. Like when ice melts in the sun, the water molecules are way more chaotic than when they were frozen, right?
Okay, but wait, if I put ice in my freezer, isn't that decreasing entropy?
Locally, yeah, but your fridge is heating up the whole room way more than it's cooling the ice, so the total entropy actually increases.
Oh, that makes sense. So you can't just cheat the system?
Exactly. That's like the whole point of thermodynamics. In an isolated system, entropy always goes up. Energy can be useful, but it gets messier over time.
Okay, so the Newton shows up and the text is like, stop! Yeah, that's gravity, guy. But like, F equals ma. Force equals mass times acceleration.
That's the whole thing, man. Force changes how things move, and people confuse mass and weight all the time.
So you're not overweight, you're just on the wrong planet.
Exactly, but then Einstein comes along and he's like, what if the speed of light is always the same no matter what? And that breaks everything.
Wait, so if light's always the same speed, then time has to be weird.
Yeah, like if two people turn on flashlights, they both see the light moving at the same speed. But that only works if time is stretching and shrinking for different people.
That's insane. So like moving clocks actually run slower?
From another perspective, yeah. And then Einstein takes it further. He says gravity isn't actually a force. It's just where space is bent.
Oh, like mass warps space-time around it.
Right, and then he drops the bomb. Energy and mass are kind of the same thing. E equals mc squared.
And that's why atom bombs are so powerful. A tiny bit of mass becomes this massive amount of energy.
Yeah, and that leads to nuclear stuff. You can split atoms or fuse them, and both release energy because some mass just disappears into energy.
The text literally says, be careful or you might blow up the planet. Laughing nervously. Dark, but like fair warning.
Then you get into quantum stuff, which is where things get really weird. Like Planck figured out light comes in little packets, not waves.
And like electrons are just like everywhere at once until you look at them.
Exactly, superposition. And the double slit experiment shows that a single electron somehow interferes with itself, which shouldn't even be possible.
That's so weird. And then Heisenberg is like, you can't even know where something is and how fast it's moving at the same time.
Right. The text describes it like one picture shows you where it is clearly, another shows you its motion clearly. You pick one, you lose the other.
And it all comes down to probabilities with Schrodinger's equation.
Yeah, it's like a cloud of where the electron probably is. Then you get electromagnetism. Charges push and pull each other, just like gravity.
And moving charges create magnetic field, right?
That's Maxwell's equations. And that's how wireless charging works. Changing magnetic fields make currents in metal.
And light is just an electromagnetic wave.
Yeah, and the frequency determines if you can see it or not.
Then zoom into atoms, protons, neutrons, electrons. Protons and neutrons are made of quarks. So like, don't play with radioactive atoms.
Pretty much. Oh, and the speed of light is 299,792 meters per second. That is pretty fast, the text says.
Okay, so Like, where does someone even start with all this?
Start with energy and how it moves around, then learn Newton stuff, then thermodynamics, then electromagnetism, and finally peek at relativity and quantum weirdness. Use the examples: dropping phones, ice melting, that double slit experiment. They stick with you.
Yeah, that makes sense. Thanks for breaking that down, man.
Anytime.